Hi, I'm Ozan. I am a software engineer at Red Hat, and I contribute to Quarkus and smaller reactive messaging projects. And in a past life, I have a PhD on IoT and autonomous application development. So if you want to discuss about that, I'll be glad that after the talk. But today we're going to talk about Kafka and Quarkus and how we are going to develop a stream processing application with it. So let's talk about Kafka quickly, then we're going to talk about very quickly, Quarkus, reactive messaging, and then I'm going to show you a demo application that I pre-developed that will go over the code. So about Kafka. Kafka is a distributed event processing platform. Conceptually, it's a log file, and you producers append to the log file, and consumers go ahead and choose an offset, choose a position in that file in which they are going to read, and they read through it. But in real life, it's a bit complicated than that because it's a distributed platform. It wants to be fault tolerant, scalable. So each log file, each topic in Kafka is divisioned, it's partitioned into topic partitions. And those partitions are replicated around the Kafka nodes. And consumers actually go ahead and read those topic partitions from their start or in any given offset. And a topic partition is totally ordered, but not the topic itself. So again, producers push data, write data to those topic partitions that gets persisted into Kafka nodes. So nodes share and replicate those topic partitions. And consumers actually can subscribe to those topics. They get assigned topic partitions, and then they start reading at some point. From the beginning or for the latest or any given offset that they want to read. And one interesting point is that at some point, consumers go ahead and say, okay, I read until that point, and they commit some offset. And at that point, it gets also written to the Kafka as if any producer will write into a Kafka topic. So a typical Kafka client application looks like that. So if you want to consume from a Kafka topic, you create a Kafka consumer. You give a bunch of configurations like consumer group ID, your serializers and deserializers, because Kafka doesn't know about your types. And then you subscribe to a list of one particular list of topics. Then you have this great while loop in which you try polling your consumer, and your consumer in the backend polls the brokers, the cluster, and it returns you a collection of records, a collection of Kafka messages. Then you can go ahead and process those records. Usually what you do is just run a computation, maybe go ahead and look something at the database, write something to the database, write to another topic. That's very common. And at some point, you finish your computation and you said, okay, I finished that. I finished processing all these different records. Then I want my consumer to say that, okay, I finished I want to commit these bunch of offsets that I processed. There are multiple problems in that kind of Kafka client application. First of all, your application your Kafka consumer needs to continue polling the Kafka call the polling method, because that's Kafka's way of saying that the consumer is alive. So you need to handle the consumer heartbeat, which is keep calling the polling method, don't block on it. So if you are writing to a database, your code is blocking or asynchronous, writing to Kafka topic is asynchronous and blocking at the same time. So So that two worlds doesn't really cohabit with each other. You need to keep polling the consumer, but you also need to usually want to do some blocking stuff, maybe some asynchronous stuff during your processing. So at the same time, again, if somehow you do that, you need to start thinking about how you are going to commit the offsets of the records that you processed. Do you want to enable the auto commit? There are multiple problems about that. How do you want to handle if you are going to pause polling the consumer? Because if you are processing some records and you are at the same time continue polling the consumer, that will accumulate lots of records in its queue. So that's another problem. Then there's the problem about how if at some point another consumer arrives into the consumer group, then there is these rebalances that will be happening because consumers in the same consumer group are sharing different topic partitions. So you get de-assigned or as reassigned different topic partitions in your consumer application. So you need to handle that, handle how you are going to commit that offset, say that, okay, I finished processing those, I can get another topic partitions assigned. And there are also lots of problems about error handling, serializers and deserializers. They are blocking actions on the object, on the byte array that you are going to receive. That's another problem. Of course, there are the retries on the producer and etc. So, so if you are going to write a Kafka consumer, don't write it like that. In Quarkus, we use reactive messaging framework to interface with Kafka. And I'm guessing that you heard a lot about Quarkus today, but I will just do a recap on how Quarkus, what Quarkus is in general, and then we are going to see how all these problems are solved in Quarkus with reactive messaging. So Quarkus is a Java framework that's optimized for container workloads. So we've seen already that, we will see also in the demo, that we generate the Kubernetes and OpenShift manifests. It results in a smaller container size, smaller application size. So that helps a lot on cloud and container workloads. We have a great dev services and dev mode in general with live load. Continuous testings, that's great. I guess we already seen that. We will see. No, we are not going to see that because I haven't written tests. And there are these Quarkus extension build mechanism that will actually do a couple of things that will optimize your application in the build time, so that your application starts faster in the runtime. And last, and that's we are going to concentrate a bit today, is the reactive core of Quarkus, which is based on Vertex and Mutiny, which is a reactive programming API. So that the reactive core actually reduces the amount of threads your application needs when running and accepting requests. And we'll see that we are not going to create threads for handling our messages. And Quarkus handles that for us. And the threading of whole system actually helps us. The reactive part of the whole system actually helps us apply the same mechanisms around what we are going to use as a HTTP request and what we are going to do when we are pushing, let's say, writing records to Kafka. All that will match in a similar programming interface, which is reactive programming. You are not obliged to use reactive programming. That's one great thing about Quarkus. You can continue using imperative programming in your usual callbacks, and that's taken into account as well. Let's give a couple of words around reactive messaging. It is a framework for writing event-driven applications. It supports different protocols, messaging backends like Kafka, AMQP, Camel, MQTT, RabbitMQ. I think JMS is supported as well. And it's based on a declarative development model on top of CDI. So you declare at the center of the reactive messaging framework is a channel. A channel is a reactive stream. On top of you pull some messages or push some messages to the reactive stream. And in your application code, you can actually inject the channel, or as we are seeing right now, declare a method on which you subscribe to a channel, and then you say that the output of that message, of that treatment, will get pushed to the outgoing channel. So in that case, if those channels were Kafka channels, we would have subscribed to in topic, do that computation, and then push the message result to out topic for Kafka. But you're not obliged to use Kafka, so you can. It can be the case that you are pulling messages from Kafka and writing to AMQP. That's totally legal. So the demo application that I'm going to show is something like that. It's it's not a to-do app, but it's I think it shows how Kafka can be integrated into Quarkus with different scenarios. So the idea about the application is that each click into a web page gets captured by awesome JavaScript that I wrote. It will get posted to the Quarkus application by HTTP, and our endpoint will write that to Kafka, a clicks topic. That gets written as a Avro model. So Apache Avro is a schema model that you can use in order to handle backwards and forwards compatibility of your model that you are going to write into Kafka. Again, Kafka doesn't care what you are writing into it. That's for you to handle the serializers and deserializers of your application, of your clients. So to go back, again, the click event will be written to Kafka topic. Then it will get read by another component. All these are the same application. I'm going to show it one single Quarkus application, but there are different components. You can go ahead and split that monolith as you wish. So the second component will actually consume the click events, persist those to a MongoDB, then write the persisted same event, but in that case in JSON to clicks persisted topic. That gets again read by another component, which in this case is Kafka streams. So Kafka streams component will consume clicks persisted, do a really intelligent stuff that I copied from internet that will analyze which elements of the DOM is clicked. It will count how many times it will clicked, and it will push that into another topic, which is clicks per element. That's self-explanatory, and then we will reconsume that in a last component that will push that into the web page through server-side events. So if all that works, and it does right now, we will see how many times a certain element was clicked on the web page. So in that application, this very simple application, there is the Kafka as service that's used, the schema registry, that is a separate part of the application, like a separate service that's used by the application, and MongoDB. The first thing that I'm going to show is actually the application that I deployed on OpenShift cluster. So as you have seen maybe throughout the conference, Quarkus makes it easy to deploy application to Kubernetes clusters. Can I actually zoom that? Yeah. Okay. So it generates Kubernetes and OpenShift manifests for you. And in that case, my application is running in that pod. And it gets connected to many services that are proposed. One by Red Hat, the Kafka streams. Another that's not showing here, I don't know why, is the schema registry. Again, that's a managed service that's consumed by the application. And the third one is the MongoDB that's imported to the OpenShift cluster, and that's the MongoDB Cloud Service Atlas that's used. And the database access of Red Hat OpenShift gets it imported with the credentials. And deploying that application doesn't really include the service credentials inside the application. All that gets binded by a service binding operator into the cluster, and the application doesn't know that these services exist. Well, it knows that it will exist, but it's not. The credentials are not there. You can see it as a volume claim of some sorts in Kubernetes. That's called the service binding. So, and the application works, saying that. Let's see. So yeah, I have my pod in here. I can actually click. I have the nice animation here that I spent hours making it. And then actually I can see that. Yeah, can I split that? Yeah. Great. When I click that, it actually counts how many times it was clicked. So let's take a look at the code. I am actually run that. I'm going to run that also on my machine, just to see how that experience works. Let's see how the application is. I actually tried to write this application live, and I was maxed out at like 10 minutes, and I didn't finish writing it. So this time I said, okay, I'm going to just show the code. It will be easier. The code is not really complicated. It's just that like writing and explaining is a lot sometimes. So when I run the application, Quarkus actually does a couple of things. Again, the build system intervenes and do a couple of things to optimize the application. The dev mode jumps up and say, actually live reloads each time you modify the source code, but it also understands how what are the services that your application needs, and starts up dev services for you. These services for you. So these are called dev services, and for me. Again, nothing was configured in the application. When I deploy, it was configured by the OpenShift with service binding operator. And when I'm developing, these services are satisfied by dev services. So I have a Kafka broker, a MongoDB, and Apache service registry that are spawned up for me as Docker containers. So let's look at the code. The first component was the clicks resource. So that's the HTTP post that I'm receiving, and I am using a construct of the reactive messaging, which is emitters. So emitters are used to push some messages into the reactive stream. So I'm injecting a channel which is called clicks out. So I'm going to push clicks into that channel using the emitter. And this time I'm using the Mutiny emitter, Mutiny is the reactive programming library that Quarkus in general use in different projects. And it actually will return a uni. This uni, it's like a maybe or like a future, or you can see it like that, which will be completed when the sending action, so writing to Kafka topic, will complete. And my post actually will complete, so return a 201 maybe, when the Kafka message is written to Kafka. But I could as well just write with an imperative way, saying that I want a emitter here, not a Mutiny API, and what it gives me is, let's see. Does this send returns? Oh, it returns a completable feature. And when I return nothing here, that should continue working. Oh, actually, I didn't show that my local application works, but oops. Okay. Some rebalance is happening. Okay, yeah. So that continues to work. So that was the first component that receives the post request and sends the record to Kafka. The second one is a processing method, as I showed in the only slide about reactive messaging. It receives from channels clicks, which is bound to clicks topic, Kafka topic, and it writes to clicks persisted channel. So all you need to do is just say that, okay, I have a method that will receive pointer events, and that will return a different kind of pointer events, which is the DTO. I should have mentioned that pointer events is a Avro generated model. I have a very nice Avro description here that will describe the pointer event that I'm generating over the client. And again, Quarkus handles that. The Avro model is generated at the compile time, and and what other thing is done is Quarkus actually detects that you are using the Avro type in terms of message input, so consuming from the Kafka topic, and it actually configures automatically the deserializer for that. So all I have to do, or actually I have to do nothing on that case. Because the Epicurio schema registry is actually used, it will configure the Epicurio Avro deserializer for that automatically. That interface is also, there are interfaces for Confluent schema registry as well that will be automatically detected as well. So in that example, I'm using MongoDB Panache extension. So the pointer event, I can't, because it's an Avro-generated model, I can't really persist that as is. So I have a real nice DTO, which will take the pointer event and create a DTO that will have all these same types, except that it's a Panache Mongo entity. And to persist that, it's very easy. Just call the persist or update. And in that case, that's a blocking action. But again, Quarkus knows that that's a blocking action because I have the @transactional method. So it will actually delegate the execution of that method into a worker thread. So I don't need to think about that. And then the actual aggregation, the intelligent part of the application, is where the Kafka streams is involved. Again, this is the I tried to simplify that code multiple times. That's the simplest that I can get. So it is consuming JSON, and I had to write the pointer event serializer and deserializer, which are just boilerplate. And normally we generate that for you when you're using JSON, except that you configuring the Kafka streams topology was much easier using that. So I just wrote that, and I won't go through it. It's just copy-pasted code, but it does the job. And what it will give me out is just a Kafka topic, so records push to Kafka topic with key as the XPath of the element, and value as number of times that was clicked. So that will be pushed into the clicks per element topic. And again, to use Kafka streams, there's a different extension. These two components were written using the reactive messaging, and to be actually use the Kafka Streams API, you have a different extension which works with all the different dev services that we are creating. So it's a coherent experience. And at last, the last component is just here, and that's how the clicks per element topic gets read. In this case, I'm just injecting the channel with the reactive streams. So multi is the reactive streams for Mutiny API. I could have said publisher here. That's equivalent. Just that. Anyways, I won't break my application now. And this reactive stream, I can actually go ahead and chain some operations as if you are applying regular functional Java. In that case, I am just acknowledging the message. I guess I'm not going to have the time to explain the acknowledgement, but negative acknowledgement. But say that usually you don't need to care about it, and reactive messaging handles the acknowledgements, which in turn in Kafka is just commit of the offset that you are processing. So that's important. And just make sure that you are not committing too often, and we usually do that for you. We have a committing strategy in which we accumulate what are the messages that you have successfully processed in your application, and that gets committed in regular intervals, like a kind of auto commit, but which actually works. So you can be sure that the processed records get committed and not actually auto commit doesn't really work because it commits in a insignificant poll, and it doesn't know which offset, which message that you have successfully processed. And in reactive messaging, we are tracking that. Anyways, in that case, again, the reactive streams gets I'm applying some reactive streams operations to acknowledge the message, so it will get committed to Kafka, and sending a tuple, just a simple key value, which will be parsed by my client application and sent through the service sends events. So that's also a JAX-RS standard. So that was it for the demo. I know that it was quick, but there are lots of things to talk about Kafka and schema registry and all the different things that we can explore again. So thank you very much. I have 1 minute for questions. Yeah.
Can you use Hey.
Yeah.
So you use Mutiny with Quarkus. Is it possible to use the libraries like RX Java?
Not with reactive. Well, actually, you can use it, but you need adapters. As it is the case with most reactive programming libraries. So by default, we are implementing the reactive messaging specification, which works with regular reactive streams, publisher and subscriber APIs. So that you can adapt to your reactive programming library of your liking. Eric Java, Reactor, etc. And we all like small I implementation also provides Mutiny APIs.
Thank you.
Well, time's up. Thank you.